So this is actually a thing. This is a thing. Okay, is one form of the AP exam harder? Last year, East Kentwood High School had 30 students take the AP Stat exam. They were informed later that the College Board gave two forms of the exam. They do give more than one, by the way. Step 9. So, which were randomly assigned to the students? Here are the results. Do you see the difference? Bum, 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 bum. Okay, so does this result provide convincing evidence that one form of the AP exam is harder? So that's the question that we're trying to answer. Identify the statistic and the parameter. So the statistic is going to be X bar A minus X bar B. So that's 4.2 minus 4, which is a difference of 0.2. The parameter is the average of A minus the average of B, which equals the true difference of mean AP exam score. Everybody good? So there are two possible explanations for why form A has a higher mean. Write these as hypothesis for the correct notation. Okay, so there is no difference in difficulty and the result happened purely by chance. So that means that our null is the mu A minus the mu B is 0. Remember, null has to equal a number. Either it's 0 or some arbitrary number. Or the alternative is that one form of the exam is harder than the other. So that's the alternative is mu A minus mu B, and it doesn't equal 0. So the alternative is mu A minus mu B does not equal 0. Yikes. All right, we're going to assume number 1, that there's no difference in the difficulty. This means that if Doug scored a 5 on form A, he would also score a 5 on form B. What is the difference in mean scores for this random I'm sorry, I jumped. The 30 AP scores from the class are written on 30 cards, randomly assigned half of the students to get form A and the other half to get form B. What is the difference in mean scores for this random assignment? So we would take the top 30 scores that we got from the class. Okay, I would take the cards, I would split them up into half, and I would give you half the cards, give you the other half of the cards. You would be form A, you would be form B, and we would find the average. Right? Does everybody see why we would be doing that? Are you sure? Okay, cool. So the mean for that would be 4.27 and 3.93. And the difference between those two is 0.34. Okay. If we did that over and over and over again, like let's say we repeated that entire process, we would get the difference of the sample means on here as this dot plot. I'm going to do it for you because we don't have enough people. Also, y'all take forever on your samples. But you didn't screw it up yesterday. I'm so proud of you. You are welcome. What, 10? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Close. Good morning, sunshine. Thank you. All right. So what do we call this guy? Like, what is this dot plot's name? Randomization distribution. Say again. So we randomize the data, and it's a distribution of the randomization.
So what happened to, so why are we using other names?
What did we use previously?
Sampling
distribution. Okay, well, we took the sample, and then what are we doing with the sample? Randomizing it to see if we get the same results. Because if you get a 5 on form A, you should also get a 5 on form B. So it shouldn't matter which group you're in, right? I feel like David's head just exploded.
Wait, what? No, you took the sample.
We took the sample. And what we're doing is we're re-scrambling it to see if there's a difference between form A, form B. Because again, if there's no difference between the forms, then you should get a 5 on either one. So it doesn't matter which group you're in, right? Right. You see how there's none of them that are at 0?
No, I'm talking about getting a 0. It's talking about the fact that they're the same. Like, how do you do it? Yeah.
Okay, so what does one dot represent?
A randomized.
A random assignment and the difference of means calculated for this assignment. Again, we took 30 cards. We assigned 15 of them to form A and 15 of them to form B. Then we calculated the difference between the two averages that we got. Okay? Hey, friend. Now, remember, there was a difference. What was our statistic up at the top? 0.2. All right, so when we look at our graph, remember, 0.2 is like right here. That's your East Kentwood results. We could also say negative 0.2. And the reason why is because it depends on which one you put first. Yes, like this could have been negative 0.2 because we could have done 4 minus 4.2. So it could also be on this side as well. Thanks. All right, so assuming that there is no difference in the difficulty, what is the probability of getting a difference of means of 0.2 or greater based on the dot plot? Okay, so based on this guy, we have 1, 2, 3, 4, 5, 6, 7, right? Or we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 plus 7. 17 out of, there should be 30. I might have counted wrong.
What's EK?
East Kentwood.
Oh.
This should have had 10 dots. Add one more.
Yeah. 5.56.
Say it again. Sorry. 17 out of 30? Okay. So on number 6, we got 17 out of 30 based on the dot plot, which is 0.56, maybe 57. That's our p-value. Okay. based on our answer to question 6, does the observed result give convincing evidence? Okay, is that less than 0.05? No, so we gotta fail to reject. So 0.57 is greater than 0.05. We fail to reject the null. And do we have convincing evidence or we don't have convincing evidence? We don't. And we don't have convincing evidence. That what? That one form is harder. Okay, so the way to remember this little like statement, remember, if it's less than 0.05, we reject the null and we have convincing evidence that he's a terrible person, right? Yes. If we're greater than 0.05, we fail to reject and we don't have convincing evidence that he's a horrible person. If he doesn't have enough money, he's a horrible person, right? Yes. The reason why we did the ones below is because if we switched, like we would have subtracted 4 minus 4.2, we could have gotten that one as well. Good? Questions?
Last word.
Yes. Flip the page. All right, on this one, we talked about hypotheses. Yet again, same. Okay. So we talked about hypotheses. And we said that the null is equal to 0, right? So mu1 minus mu2 is equal to 0. And the alternatives is really just anything else. So mu1 minus mu2 is greater than 0, less than 0, or does not equal 0. It can be any one of those. We didn't use the conditions on this one, but in this next part, you're going to use the conditions because you're doing the 4 C's again. Okay. You need to make sure that they're random and dependent trials or samples. 10% condition, you're going to only check without replacement. Here's a new part. This one's a little weird. With the 10% condition, you're going to only check when sampling without replacement. And N1 is going to be less than 10% of the big N1. So your big sample. So for instance, on the last one, it would be 15 is less than or equal to 10% of 30. Because 30 was our actual sample that we pulled. Huh? The answer is no. Right. So then you would say, then you would try to check and make sure that it fits the normal condition.
Wait, so
So the 10% condition wouldn't have worked for the last one, right? But is that a normal distribution? Does it fit the CLT?
Yeah.
Okay, then we're good.
So if it's normal, then we don't have to do something.
You just have to state it, but it's okay if it doesn't work. I feel like stats just kind of makes up their own rules. It's like, hey, check these conditions, but they don't have to work.
But like, so the reason why they, you don't have to do 100%, and you say, only check when they put out the person. So like, and we've already not like, sometimes you don't have to do that, because like, the purpose of 100, is the purpose of 100% to like figure out whether you create a person. So. Those are person.
When you can't, like, 10% is not gonna work. So, just take it. Just take it out. Is that what you're talking about? No, we'll talk later. Go again, David? Oh, okay. Sorry. All right. So normal. Okay. Both populations have to be normal. Okay. Again, we've got to follow the CLT rule. So greater than or equal to 30. Sample has got to show no strong skews or outliers. Strong skews or outliers. That's when you're going to multiply by that 2. Yeah. Okay. So what I want you to do is go ahead and try the check your understanding. So you're doing the choose and the check. Okay. The choose and the check. All right. So go ahead and take a couple minutes. That's what you're working on. All right, last year, East Kentwood High had 30 students take the AP stat exam. They were informed later that the College Board gave 2 forms of the exam, which were randomly assigned to the students. The 2 forms had a difference in means of 0.2 as their convincing evidence. Complete the first 2 steps and of a significant test. So, what is the procedure? 2 sample t-tests for difference of means, or you could say mu A minus mu B. Yeah? So when you want to put, you can put the notation or you can put it in words. You could say difference of means, that's okay. It's T? I don't know. What does Z actually stand for? Yeah, but like, what does the Z stand for? Standard deviation? What? Okay, we're gonna look it up in a second. I don't actually know what T stands for. That's a good question.
I think.
Crazy. 0.05 for our alpha. And then we said x bar A minus x bar B. That's 0.2. The evidence for the alternative is that XA minus XB is 0.2, which does not equal 0. Cool. All right, the parameter is mu A minus mu B, which is the true difference of means for AP exam. Plus. And then our hypothesis is that HO is equal to 0. And HA does not equal 0. So mu1 minus, or mu A minus mu B, God bless. Mu A minus mu B. Okay. All right, check the conditions. Check the conditions. So, does it say randomly assigned? Yes. So what can we do? Can we show causation or can we generalize to a population? Mm. 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 It shows causation. Why? Randomly assigned to students and then random sample, right? Huh?
Why is it not being one?
They're still talking about the dang shirt. Go ahead, Vic.
For me, I can write out statement for that. I just think of what we're trying to find out of, like, the question. For whenever it's generalization, we're trying to make the assumption of the population as an characteristic. But for causation, it's trying to see if there's a link. So this one, the test scores and
The form.
the exam.
That it doesn't add up simply because if you're generalizing to a population, wouldn't you also need to find if the thing is true?
Do you know if
It's the same thing.
does every school receive 2 forms of the AP exam? No, we don't know that. But we know about this school that they had 2 forms.
Well, all the schools, one school. I thought that the West Coast got one fully East Coast.
That is a true statement. But in this school, they got 2.
Here's a little thing, you know, given the question, we're trying to not generalize it, but
But how are you saying not to generalize it and then explicitly say like then specifically to this person? It happens it happens to you, know, it doesn't say that it was everything, you know.
how do you?
But how do you know?
Stevie, that, look, what about secret? This is like the MP exam that only East Penfield had. And no one else actually took this AP classes with the test it. We don't know. We don't know. We don't know.
That's the thing about generalization.
Weren't we the only school that did like the AP African American Studies exam last year? Or like the only school system? Like not everybody in the state of Georgia was able to administer the AP exam for that one. There was pilot schools. So we can't generalize to the population because there was only like one school that was given it.
Already have the top, you know, we have the nurse students. That really blow it down.
Why is that? Because there's like
Only something is for generalization or for causation. There's a random assignment versus random sampling, which is so easy, so simple. Because we don't do it. Trying to figure out the average, like, body temperature is like 90.6. Why are we trying to find causation? What's the cause? Are we trying to figure out the climate change caused it? No, we didn't study for that. We're just trying to find the ground body temperature. What causation is there to find? That's why, that,
aren't you trying to figure out what?
well, how would we figure out the cause from what we did for the body temperature? I think that we are researching more and not because realizing the population of the body temperature is different.
You good, homie? And came 10 minutes later, randomly assign versus random sample. That's what you're looking for. Yes? Okay, 10% condition. 10% condition. Did we do any sampling here? After we got the 30 scores, did we do any sampling? No. Okay, so no sampling, but we didn't check this one. Okay. Normal, we had NAB15 and NB, God bless, NB15. The CLT is 30, which is greater than or equal to 30, right? We have 30 in total. So CLT works.
How do you separate the names?
Because we did a sample. And I'm sorry, what?
So I NA and B.
Because we pulled 2 different groups.
How does it?
They did not take the same AP test. They did 2 different tests. That's the 2 different tests. I mean, it's not like they didn't see what's going on the test. They took something. That's the something. Oh my God. I'm gonna get this out of
Okay, really quick, if we graphed this, so if you looked at the previous page that has like the list of all of the data for the 2 groups, If we put this on a dot plot, watch what happens. So you get 1, 2, 3, 4, 5. 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7. 4, 4, 5. Yep, that happened. Is this normal? What is it? It's skewed just a little, like a little bit, right? Okay, so it's skewed. Okay, so you need to proceed with caution. I know, sketchy. Okay, so when you look at this, it's not really normal. There's a little bit of influence on it, right? The data from the front page. Yep. Right. Flip the page when you're done. All right. So does a multivitamin improve your memory? Researchers from Harvard and Columbia University wanted to know if taking a multivitamin improves memory. To investigate, they took 3,562 volunteers and randomly assigned half of them to take a multivitamin every day and the other half to take a placebo. Here are the summary statistics for the scores. Is there convincing statistical evidence? Blah, blah, blah. Okay, what kind of procedure? Okay, so 2 sample. Test for M1 minus M2. Parameter is at the true difference of mean memory test score. All right, your null is that mu1 minus mu2 is 0. And the alternative is that it's greater than 0. Why is it greater than 0? Okay, so we're doing multivitamin minus the placebo, right? Okay, the statistic that we have is x1 minus x2, which is plus 1.4. And the significance level is 0.05. Evidence for the alternative is that x1 minus x2 is 1.4, which is greater than 0. All right. Does it say randomly assigned or does it say random sample? Okay, so we can causation. Okay. We're not going to check the 10%. Why? Say what? Not sampling without replacement. So large counts is 1,781 bigger than or equal to 30. Why did I pick that number? Right, half and the other half, right? And central limit theorem, right? Everybody good so far? Now we're going to do our calculate portion. And so that's going to be test statistic is equal to statistic minus parameter divided by standard error. What's the difference between standard error and standard deviation? The formula looks a little goofy. P is equal to x1 minus x2 minus mu1 minus mu2 divided by the square root of s1 squared divided by n plus s2 squared divided by n. And this is n1 and n2. All right, take a moment, plug in that information. All right, really quick. When you plug in these numbers, you should have gotten 2.25. Yes? Not the short. Okay, so your test statistic is 2.25, and your degrees of freedom would be 1780. Okay, how do you plug this into your calculator?
So menu,
Go to menu.
that has two standard pieces.
Say it again. Stat. Menu stat. What? Stat test. Then. And then plug in the info, right?
Is that what Boston used?
Is that what?
Boston used?
For.
It's fun.
That was funny. Then certainly I went, ha. That's it. That's all you get. All right, so your p-value should have been 0.0123. Is that what Boston used? Very fun. Menu. Did you put data or did you put statistics? Statistics. So X1 is what? Oh, yeah. Hey, for your p-value, you got 0.024 off the calculator, right? Yes, no? What'd you get? Don't lie to me. Did you get 0.0123? Caitlin, what'd you get? Okay. And we're greater than. Oh, that's true. There you go. Okay. I was like, that's not right. But yeah. Because if you put does not equal 0, then you could take that answer and divide by 2.
Yeah.
And that gets you 0.0123. That right? Everybody? Okay. All right. Conclusion. Assuming the null, there is a 0.0123 probability of getting x1 minus x2 or greater of x1 minus x2 of 1.4 or greater, purely by chance. And then we've got to say, because 0.0123 is less than 0.05, we reject the null, and we do have convincing evidence that multivitamins improve memory. which is a true statement anyways, right?
Well, it's,
Do y'all take the Flintstones? Do y'all take the little Flintstones?
I think I
Losers.
was listening to you, like, but what did she say?
Those like chalky Flintstones when I was a kid.
Those are good.
They're like mid.
I love them.
You maybe took too many.
Yeah.
All right, so base, where have you been?
Water.
In the like Sahara? All right. So based on your conclusion from the significance test, which one of the two errors, type 1 or type 2, could have been made? Interpret the consequence of the error in context. Is this type 1 or type 2? Okay. So if Mo goes and eats a whole bottle of Flintstones vitamins, is that going to improve his memory? No. So no. No. Okay. So we decide multivitamins improve memory, but do they really?
No.
But they actually don't. So people are wasting their money, right? So this is a type 1. It's where we accept the null, but we have evidence that the alternative is true. Right? Say again. What you said. Say it again. We rejected HO. So it's no, this should be type 1 though. Here, look at the difference between these two. This little chart does a good job. Okay. So type 1 is we reject null and we have a false positive conclusion. So our conclusion was we reject the null, but we have convincing evidence that they improve memory. But again, Mo just ate an entire thing of gummies or Flintstones vitamins and he's overdosing. Did it improve his memory?
Yeah.
No, he's just gonna pee a lot, right? That's probably what's gonna happen. Yeah. That's a type 1. Good. Okay. Go ahead and flip the page. No. I really don't want to rewrite this. Okay, these are the choose, check, calculate, and conclude. It's what we've been doing. Yes? The only thing that's like new, if you will, is the formula. What I want to do one day after we finish this unit in particular is I want us to do our own formula sheet and actually like make it make sense. Like list out what it actually is versus just having random numbers on the page or random letters on the page. All right, go ahead and do your check your understanding. All right, let's finish this up. Okay. So, according to a Stanford business, what? Americans may eat fewer calories at restaurants if the calorie of the food items are labeled on the menu. False. False statements. Nope. To investigate this, researchers compared Starbucks receipts from locations where menus were labeled with receipts from the stores where the menus were not labeled, blah, 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 blah. All right, cool. This is a great thing to have like on an FRQ. This statement right here. Okay. So we're gonna choose a 2-sample t-test for the mu1 minus mu2. mu2. Alpha is 0.05. Your x1 minus your x2. Oh, it's that time of day. It's going to be -40, which is evidence for the alternative because it's less than 0, right? Okay. Your alternative, I'm sorry, your HO is mu1 minus mu2. Your alternative is less than 0. Okay. For the check, assume conditions are met.
Yeah.
We don't have to do nothing
Why?
because it says assume conditions are met.
You did not read.
David. Shameful. Okay. All right. So for calculate, when you plugged in all that junk, you should have got -1.84. They might need to see how you do that. Everybody okay? All right. For your p-value, what'd you get? Joke's on you. I'm not doing it for you. P-value. Boiled again. Go plug it in, yo. Because the problem is you don't know how to use your calculator and then you try to figure it out on the test and then you fail. Do better. Hurry up. Also, for your picture, you should have 0 and then -40, and then you're shading that region in. You know, Mo, we know you're in your feelings, especially after your Flintstone multivitamin consumption, but no, I ain't no DJ. We ain't turning it up. Bro. Right, the T is -1.84. The p-value is 0.038. Okay, we're gonna assume that the null is true. Then there is a so 0.038 is less than 0.05. We reject. But we do have convincing evidence that the labeling the menus reduces calories, right? Okay. Homework. Homework.